Let's try that again. Hello and welcome to part 2 of our three-part webinar series on threat hunting. I think everybody should be able to hear me now. A couple logistical things. We will be making these will be recorded and made available after the broadcast. Anybody who did register should get an email with the links to that, and we will post those, and this will be the same for all 3 parts. Will be available post broadcast. Also, if you have any questions throughout the presentation, please post those in the question sections, and I will try and grab those throughout the conversation and bring those up to the presenters. So part 2 of this series will be on testing visibility and specifically around your threat hunt. We will be going over specifically some information around privilege escalation, reference to the Empire post-exploit kit. I'm Joe Moles. I lead the customer security operations team here for Red Canary, and with me is also Jimmy and Adam. Jimmy and Adam, I'll let you guys introduce yourselves.
Hey everybody, I'm Jimmy Astle. I'm a senior threat researcher at Carbon Black. I specifically focus on our applied research side, so long-term and short-term security efficacy in the Carbon Black product stack.
And my name is Adam. I am an incident handler and the director of Beards at Red Canary, and I focus on helping customers in times of crisis and helping them grow their security programs.
So a couple things, tools that we'll be talking about today. We're going to be talking about the MITRE ATT&CK framework and some of the tools that MITRE has put out related to that. We're going to be using CB response, and then also the Atomic Red Team is the testing framework we'll be talking about today. So we'll have more information about each of these tools throughout. Also not presented here, as I mentioned earlier, we are going to be referencing PowerShell Empire, which is the post-exploit kit that we'll be using for kind of a background reference to some of the activity and tooling around this. So what we're going to do today, we're going to be demoing an actual threat hunt and how we're using the MITRE ATT&CK framework to pivot off of that into CB response, and then using the Red Canary Atomic Red Team testing framework to actually validate and test that visibility in your environment and your threat hunt hypothesis, and then how we use information from things like MITRE to actually frame those threat hunts, build those hypotheses, and really drive this into a regular cycle of hunt, validate, test, and through that life cycle. Oops. Sorry. There we go. Sorry. Live demoing. All right, I'm going to kick this over to Jimmy for his live demo here. So stand by just a second while we switch presenters.
All right, GoToMeeting says that I'm presenting my screen. If I get a thumbs up from someone, I will continue.
It looks good on my end, Jimmy.
Awesome, thank you so much. Okay, so thank you for framing that, Joe. And so, we're talking about threat hunting, and I think one of the things that Adam and I talked about when we were brainstorming for this presentation was sort of, to steal his term, demystifying the threat hunt, right? I think oftentimes you think about when you're threat hunting as this really hard problem, or you don't really know where to start. And so this is sort of where MITRE ATT&CK comes in, right? Is you can sort of create a game plan and come up with what you want to hunt for, right? It's sort of, you want to sort of follow that scientific method, right? You want to hypothesize of like, hey, today I'm not going to hunt for everything because you're never going to come up successful. So you really need to scope it down to something that you want to look for, right? And while you're threat hunting, not only is it about finding the bad guys in your network, but it's also about learning, right? Take it as an educational moment to sort of dig into the weeds of not only the behaviors that you're seeing, but how do these things actually work, right? Because in the long run, that's going to pay off tenfold, not only for yourself, but I think for your company as well, right? And so in this specific case, you know, as Joe alluded to, we're going to talk about privilege escalation and specifically bypassing user account controls, right? And so for those who aren't familiar with MITRE ATT&CK, you know, it's a knowledge base that sort of overlays attacker behaviors onto the cyber kill chain, right? The NIST cyber kill chain. And so what's really cool here is they have this MITRE ATT&CK Navigator, what you're seeing here on the screen. And this attack navigator you can run in the cloud, which I'm running here, that MITRE hosts on their GitHub page, but also you can run this locally in your own network. And what it does is it takes all of the MITRE techniques and puts them in like a nice visual representation, right? Humans like to see things visually. It's a lot easier for us to like conceptualize and look at stuff. And I think, like for me at least, this is like a really easy place for me to start, right? When I'm threat hunting, but when I'm trying to come up with sort of research ideas and stuff like that, right? Because it kind of lines it all up. And specifically, when you interact with this, right, you can see right away, bypass user account control, you know, it pops out and says, hey, it's T1088. And I can see that not only is it under the privilege escalation, you know, swim lane, but it's also under the defensive evasion swim lane. You know, and what else is neat? They have these layers, right? So right now I'm scoped just to Windows and I'm in the attack act stage, right? So this is like the traditional attack stage. And so, you know, what does that look like? If I want to research more and learn more about user account control, how would I do that? So all you really need to do is just right click, say view technique, and it's going to take you over the MITRE wiki here. And so for those who aren't familiar with user account control, that's that awesome window that pops up all the time when you try to install software, right? And depending on how your group policy is configured in your network, sometimes you just have a yes or no. Other times you have to put in a username and password. So what we're going to be talking about here is how do you bypass that? And so what does that mean? So if you have a piece of malicious code and there's a user in the administrative group on that machine locally, and it just tries to run automatically, user account control is there to sort of to impede that flow of auto elevating, so you get prompted with that, right? But it's been documented that it is not a security boundary and that bad guys have found their way around this. And you know, MITRE's done a really good job of sort of talking about what it's for, talking about ways to mitigate bypasses, and then I would highly recommend after this to check out this GitHub page of this UAC-me repo. This repo has like 50 plus UAC bypasses, some of which are still, that'll still work on a fully patched Windows machine. And at Carbon Black, we've actually seen malware samples that are actually copying and pasting code from this repo and using it as part of their privilege escalation techniques. And so, you know, when you're walking through this wiki, you know, at the top, you get, you know, a quick summary of what's going on. In the middle, you have examples. So these are like real, live, you know, documented tools or threat actors that are sort of doing these behaviors, right? That MITRE has documented. And then they'll sort of talk about, hey, here's how you mitigate. I know this is everyone's favorite. Don't put users in the local admins group, but we all know sometimes that's not possible. And so how do you sort of mitigate this from like a security tool perspective, right? And so today, what we're going to go through is two specific UAC bypass techniques. Both of them are patched in Windows, but I think they still give you a really good idea of like what it's like to threat hunt and what it's like to look for like these specific characteristics. So we're going to look at event viewer bypass, and we're going to look at this SDCLT bypass. And both of them essentially at a sort of high level, like how do these UAC bypasses work? So these binaries have a special sort of attribute to them, so that when they execute, they're actually allowed to auto elevate their permissions so that you don't get that prompt, right? And in these specific cases, they're reading from these registry keys. And so if you put your bad binary or you put a pointer to your bad binary in these registry keys, when you run event viewer or you run sdclt.exe, it'll actually proxy the execution of whatever is pointing to that registry key, right? So it's super interesting, right? It's certainly not a vulnerability, right? But again, it's an issue that sort of implementation-wise with some of these higher privileged binaries. So we're going to pivot over to CB response, and we're going to sort of start a hunt to see what this looks like.
So one question while you're making that pivot, Jimmy, that came in.
Yeah.
The question is, you know, with many EDR platforms, including CB response, CrowdStrike, Cybereason, a lot of, you know, the MITRE ATT&CK techniques and such are now built in as you know, can detects and everything like that. So where's that differentiation between a threat hunt and what's kind of canned, and where's the value, you know, the value prop there?
Yeah, that's a really good question. Actually, we just went through the MITRE EDR evaluation, the attack of EDR evaluation last week, and we have our own attack feed that's built into response. And one of the ways that we sort of look at it is you have these higher fidelity queries in any EDR product in general that, hey, when this fires, that a bad guy is doing something, right? And so you sort of use those as your indicators to sort of lead you to like scope your visibility, right? I want to look at this one thing. And then I think, from all the other sort of MITRE related techniques that you see in this navigator, you're not going to want to alert on everything that's in here. You're going to get overwhelmed, and that's sort of not the point of the MITRE ATT&CK, right? You really want to leverage these to sort of steer you where your hunts go, right? And like I said, think of it as like a map on how to navigate. And one sort of thing, right, is if you're detecting an adversary in the right-hand side of the kill chain, that means that the adversary has already executed everything to the left prior to it, right? And so this is sort of like your map of being like, okay, they did a privilege escalation, which means they had to get code execution. So let's try to figure out where they got that code execution. Does that answer your question?
It works for me, so.
Cool. So like I said, I'm going to talk about this event viewer bypass here. One of the really cool, powerful features that we use a lot for research team in Carbon Black is the file integrity monitoring feature inside of CB Response. And so essentially you can point CB Response at any file, any path, any registry key, or any registry hive. And anytime one of those is modified, you're going to get an alert, or you'll get sort of data that will lead you to that. And so, in looking at the MITRE framework, we can see here that this specific one, modifies this key. And what's interesting here is this is in the HKey current user hive. And right, you don't need admin rights to modify that key, right? And that's why this is so important, that without admin rights, you can modify this key to then get to that sort of admin token, right? The ultimate sort of where the adversary wants to get. And so what I did is I just put our regmod sort of prefix in there, and I put the path in to where we think that the adversary would be exploiting this UAC bypass. And as Joe said, I use PowerShell Empire, the built-in PowerShell Empire privileged escalation techniques. And I'll sort of dig into the source code on that later on in this demo. But you can see right away that we see that PowerShell is modifying this registry key, right? We can see that there's 14 reg mods, some file mods, a network connection, and it has some child processes. So right away, right, like PowerShell modifying its registry key, that should never be normal, right? That's certainly something that piques my interest, right, from like a threat hunting perspective. And so if we pivot into that PowerShell alert, right, I have the PowerShell process here highlighted, and you can see right away we have this really long encoded command, right? So if you base 64 to code this, you'll see like the quintessential PowerShell Empire, downloaders and AMSI bypasses that kind of just come out of the box built into the product. And you can see like the user that executed it. You get some context on PIDs. But what's really neat here are the child processes, right? Like right away, like I said, humans like to like conceptually visualize things. I think it helps us like learn and really kind of dig in, right? And so right away you see these event viewer processes, and you see this who am I process, and you're like, okay, that's interesting. And so what I can do is I can click on this regmod field here, and it's just going to show me the registry modifications that took place. And again, we're validating now with 100% certainty that, yep, PowerShell certainly modified that registry key, and I see event viewer being executed. So to me, this smells, looks, feels, everything, right, like a UAC bypass. So it's pretty neat. And so, well, what happened? It's great that, we detected this, but, can we kind of understand like what happened after this was executed? And so if we click on this event viewer, we'll see right away that it spawned a child process of PowerShell, right? And then we can click on that PowerShell process, and we'll see again, essentially two PowerShell commands chained together. We're setting a variable here, right, of this HKey current user software update and this .update object. And then we're chaining that essentially to this encoded command $x, right, which you're seeing being created right here. And then again, that gets executed, and then the PowerShell stuff will sort of take place in the background, right? So you'll get callbacks, and this is obviously a PowerShell stager that's calling back, that's now running in an elevated admin context. So it's like, so what have we seen here, right? So we've sort of hypothesized about an event viewer bypass. We've put in the search, right? We've hit that. We've gone in and we're like, okay, this is certainly a bypass. So it's pretty neat, right?
So here's another question that came in just looking at this chain of execution here, Jimmy. One of the questions was, why, if this is the privileged escalation happened at the event viewer, why are we seeing the who am I from that parent PowerShell instance? Is there any information we can pivot there for future hunts?
Yeah, let's check it out. So we can click on this who am I process, right? And so this is a binary built into Windows that IT admins can use to enumerate groups on machines, right? And to sort of see what context you're running in, right? Linux has the same exact thing. And so you can see here that before this privileged escalation ran, it wanted to check to see if this user was in the members of the admins group, right? And so why would you run this privilege escalation from like a red teaming operational security perspective if you're not in the admins group, right? You would blow your cover right away. And so this is sort of like we like to call it like a pre-flight check from a red team perspective, like, hey, are you in the admins group? Perfect, let's move on and perform that privilege escalation.
Thank you. And one other question that came up on detecting this type of stuff, or the question was, would we need to collect binaries? So, Carbon Black response can collect and binaries from the local host. But for this type of attack, would we need that binary collection, or could we do it with just the telemetry?
Yeah, it's a good question. I think we've been seeing this over the past couple of years, that right, adversaries can just live in memory, right? And they don't need to drop binaries to disk, right? And so in this specific case, there are no files that touch disk, right? This is, PowerShell running and kind of that PowerShell process is running, right? But it's in memory doing its stuff, and you can easily pivot or inject yourself into other processes to masquerade. So yeah, like I don't think you would need to do a binary collection on this specific one. But say like, for persistence or, something else, for command and control, crypto mining, whatever, right? They drop something to disk, we would have a copy of that binary for further forensics analysis.
Cool.
So I just wanted to sort of show you kind of one other example, that SDL CLT bypass, right? Very similar in actually how it executes. And again, you can see PowerShell, modifying that registry hive, right? And we pivot again. It's an Empire thing where it does the who am I enumeration. And you can see that the SDCLT, child process. And again, you see the PowerShell. I think what's really neat here is you can see the command lines of that SDCLT process. And what's interesting here is the researcher that discovered this, they had opened this binary up in IDA and noticed that it took a kickoff elevation command line parameter, and that's what actually does that auto elevation and allows the sort of UAC bypass. But again, very similar traits. And I think sort of when we talk about hunting, right, we talk about sort of artifacts that we discover while we're hunting, right? Like we were looking for that one registry key to sort of key off of this, right? But we've already, as Joe alluded to, we've already got a who am I process spawning out of PowerShell, right? So that could be a threat hunting query that you could have right in your toolkit. But also you notice that this registry key again is modified, right? And so we could easily create another registry key to just say, hey, anytime this hive is updated or is modified, I want an alert on that. And again, this is a sort of a quote unquote masquerade of a Windows key to make it look like a legitimate Windows key, but Windows update keys are usually never in the current user hive, right? And so right away, that's sort of another indicator that we can pick up from this threat hunting endeavor, right? But again, you sort of get that full picture, and it sort of really gives you that sort of root cause of what happened, what the adversary kind of did, and what they were going after. So one last thing I wanted to do, and I talked about this early on, was sometimes as defensive researchers, we say, who cares about the red team? Or, I got so much other stuff to do in my daily tasks. Like, I don't have the time to go research that. I can't stress enough, like, how important it is to leverage tools like PowerShell Empire, right? Not only is it an effective post-exploitation framework, but it's like really, from a research perspective, it's really interesting to see, how some of these PowerShell ninjas coded up these modules, right? And since it is open source, right, this is why open source is so great, right? That's why the atomic tests are so great, because they're open source and everybody can see and contribute. And so you can see right away, if we look at the source of this PowerShell file, right, because you see under module source, privilege escalation, event viewer bypass, PS1, you can dig right in, right? And you can see right away that we're running who am I groups, and we're looking for the SID for the administrator groups, right? The system identifier that's unique to administrator groups on all versions of Windows, right? So right away, that's a dead giveaway of what we just saw in CB response, right? It's really neat to kind of visualize what this code looks like. And then you can see right here that we're storing our payload. Hey, look at that. There's that, Windows update key, right? So again, really cool to kind of see how that's being utilized from an offensive perspective, right? And then finally, here's our command where we're putting this PowerShell one-liner inside of that registry key. And then down here, right, we're going to invoke that key, start an event viewer, right, with the start process PowerShell commandlet. And then finally, we'll clean up after ourselves. We'll be good red team OPSEC folks, and we'll clean up after ourselves. And so both of these are open source. They're in the PowerShell Empire source. And I would highly recommend, sort of when you're doing these hunting, like definitely, go read the manual, go read into this stuff. You'll learn a lot from it.
Excellent. Cool. We're gonna switch. I'm gonna switch back to presenter here. So give us a second, and then I'm gonna hand it over to Adam to talk about testing.
Yeah. So while we're kind of pivoting over, so when I think about threat hunting, Jimmy did a great job of kind of going through the hunting analysis. Like, this is how you have this idea, this is what you go looking for. One of the things I'm a firm believer in is once you have completed your hunt, there should be an output, right? You should have something that says, I hunted for this thing, and now I'm going to automate it going forward. So as you might have seen on those previous slides, once you have your query, you found your thing or you didn't find your thing, there's a way that you can save this. And you can say, like in CB response specifically, there's the idea of watch list that will kind of be querying for things over time to alert you if it ever happens again. But any system that you use, you should have some way to alert and say, hey, that thing that you went looking for and didn't find, I think I found it, right? So that by that way, you're trying to almost hunt yourself out of a job. But of course, like with the way tradecraft works, it's never gonna happen. So,
yeah.
so
thank you for that, Adam. I forgot to mention that. Yeah, in those queries, you can literally just hit add to watch list, right? And like you said, like you put all this time and effort into hunting, like you don't want that to go to waste, right? You should be able to do that from here on out, right? And so that's one of the sort of powerful things of these watch list concepts, where from here on out, all the data as it's being recorded on the endpoint and sent up to the cloud, right? It's gonna immediately fire when it sees that pattern of behavior on the endpoint. Thank you.
Yeah, absolutely. Yeah, it's just sorry, go ahead, Joe.
I was gonna say one question related to that was somebody asked if some of these hunts and everything if there's any that are canned or built into Carbon Black Response or are available through work that Jimmy and his team are doing.
Yeah, absolutely. So that's the team that I work on. That's what we do all day, is we're sort of constantly in this hunt mindset and doing research internally. And so the product ships with what we call threat feeds, and those are sort of the output of not only what we do in the threat research team, but it's also the output of our Carbon Black community. So all of our customers have the ability to actually say, hey, I think I have this query, and they'll sort of vote on it in our Carbon Black community, and that'll actually get added in, and we'll give credit to the customer that did it. And actually, during our MITRE evaluation last week for CB response, one of the techniques that was caught was actually from a community feed. So it was really cool to kind of showcase that and show it. And we're giving accolades to the gentleman who had given us that query.
Excellent.
Yeah.
Cool.
So kind of pivoting a little bit from the hunt perspective is how do we incorporate testing into this process? And kind of before I get into, nope, stay on that, Joseph. So before we get into kind of like how to test, just a couple of words on the validity of testing. So not only is testing good for testing your detections, so we talk about that output from your hunt, making sure that those things work the way that they should, that they're finding the activity you expect, but it's also in organizations where you may have a couple of people that are working on this. You might have hunters, you might have red teamers, you might have some of those people playing both roles. It's good to have something to hunt for. So if you're just kind of blindly out there looking and say, I think that I'm hunting for this technique correctly, if you don't have something to reference, you might think, okay, I went looking for it, it's not there, but you had a busted query. So, it's kind of a way that you can either do something and then rehunt for that thing and say, okay, I didn't find it originally. Now I've done some due diligence. I've put some activity in my environment. I'm hunting for it again. I found it like I expected it to. It's a really valuable thing across the board. Testing is critical in pretty much every aspect of your security program. If you don't test it, you don't know it works. So with that in mind, want to talk a couple minutes about this project we come up with called the Atomic Red Team. And the idea of the Atomic Red Team is to enable rapid iterative testing to enable you to grow your security program and build its efficacy. So it's highly, it references MITRE ATT&CK heavily. It kind of maps to the techniques and tactics in attack. And the idea is to give you a very quick way to go from, okay, here's the technique that I think might be going on in my environment or we might be susceptible to, and being able to test that and see, do I have anything in my environment that, that prevents this, or at least gives me the visibility that I need to see it. So that's kind of the idea. We kind of took the idea of unit testing from the development background of what's the smallest conceivable test that we can put. And in most cases, it's a simple one-liner copy paste that you can run, and then you can validate, do I have any visibility on this thing? Okay, now you can go to the next one, Joe. So this next slide is kind of just a view of the Atomic Red team. It's totally open source out there for public consumption. You can start using it today. It's just a bunch of different tests and different ways that you can leverage them. So if we go into the next slide. So one of the ways that you can use this is, we have this index that we create kind of dynamically when new tests are contribute. You'll see those big contributed tests down there. So some things don't necessarily lend themselves to the unit test, the very simple test that I referred to. Some of those things require outside tooling or, actually modifying binaries. So some of them we just simply haven't created a test for yet. So just kind of a plug, go out there and contribute some tests. But the idea is, you can pivot directly from MITRE into something like that, find the techniques you're looking for, and then start running tests very, very quickly. And this is kind of like the high level testing cycle, from my perspective. This is kind of how you iterate through these tests. So you find a technique like UAC bypass that Jimmy walked through. You say, okay, I need to test and see if there's anything in my environment that can find this. I need to maybe stage some stuff so I can hunt for this. So you test it, or you test some kind of permutation, because most of these techniques, there are many, many different ways to execute them. So it's very rare that you have a silver bullet for any of them. So once you've run your test, did you detect it? Did your hunt result in it? If it didn't, then you have to look and say, did I even have the tools that I need in my environment to find this thing? Do I have something, Jimmy showed in the Empire loader, it's this big, giant, obfuscated text string. But if you don't have command line visibility, you're not going to find it. You're going to have to find it somewhere else down the chain. So it's one of those things, like, if you don't have the visibility, go get it. There's plenty of places you can get it. Like, there's plenty of open source tools. There's Sysmon, and you could start doing this today. Like on the Mac side, you've got Super Audit, you got OS Query. So a lot of different tools that you can use like right now to get some of this visibility. But if you don't know that you're missing it, then you don't know. But if you do have the visibility and you just didn't find it for whatever reason, maybe your hunting query is messed up. Maybe you're not looking for the right attributes. Maybe your detection capability that you've built isn't tuned correctly, or it's tuned too full, too much, so that you don't actually see the thing you're looking for. But everything, as you notice, goes back to testing, because at the end of the day, this is not like a one and done. This is let me continue to test so I can iterate through this. I can continue building out my detection, build out the rest of my security program, because that's how we get better.
So one question that came up related to this, and this is a question to both of you, from the other side of what base knowledge do you need, or is kind of key to jump into that threat hunting activity in this whole life cycle?
Jimmy, you want to take swag at that one first?
So you're saying, like, in a sense of technology-wise, or just?
Well, so the specific question, is there any like prerequisite knowledge? So do I need to know a programming language? Do I need to know operating? What information and or what sources should I kind of start wrapping my brain around to get started?
I think oftentimes we see that misconfigured IT systems, right, are like lead to a lot of these types of security incidents, right? UAC bypasses, someone's in the administrator group. I couldn't stress enough, like, going through some of like learning more about Microsoft Windows internals and like sort of how domains work and what are user SIDs and what is a system GUID, and what are group policies and how do I apply group policies? Like, all of these concepts from like a Windows IT perspective is like invaluable when it comes to a defensive stance, because you have to know all those concepts in order to defend against them, right?
Yeah, and I would say, you know, if you're looking for a place to start and you just feel overwhelmed, Attack is a really great reference because they have already done the hard work of tracking the actors, tracking the tools they use, tracking the techniques. And in most cases, they will show you some kind of example of like, this is how they did it. This is the tool they did it with. So you're not starting from scratch. You're starting from a known database of like really rich knowledge. And that will enable you to very quickly pivot and say, hey, I don't need to know everything about everything. I just need to know enough about this particular persistence technique so I can go start like getting better at it.
Yeah, I can't tell you, Joe, how many times we go down the attack rabbit hole here at Carbon Black where we get kind of led on to something and then you kind of dig in and you're like, I didn't even know that was a thing, right? And it kind of just brings you all the way down it.
Today I learned.
Yeah, exactly.
Yes, right.
Always learning.
Yep.
Right.
So, and I'll just to chime in on there also, this is one of the things I always tell my team is, if you're going on one of these hunts, this is a great opportunity to engage with your data and even just understanding your environment. Even if you don't find something, you should still be having something that you're taking away and you're learning in your environment. You're learning how this data looks. So it's a great way to engage and understand your environment. So cool.
Right. So on the next slide, we'll give you just kind of a basic workflow of like how you can test in an atomic manner. So one of the things, like the very early stages of like PowerShell Empire accessing a system, you're going to see PowerShell, right? So PowerShell is one of those things that is used heavily by good and bad guys. There's so many different ways you can obfuscate it, that you can use it to do things that, you know, no one would expect or think about. So there's a lot of evil that's being executed with PowerShell today. So if we kind of go on to the next slide, we can kind of look at the this is straight from the PowerShell Empire documentation. So Stagers 101, it shows you kind of what a PowerShell stager would look like. So that running that PowerShell string, that's going to get you your foothold on a system. What you notice is there's this -enc, so this encoded command that Jimmy went over earlier. Looking for encoded commands is a great way to find boatloads of evil, because it's something that you can do as an attacker that very, very quickly defeats like so many different string-based detection criteria. So if you're looking for something that says Empire, you're looking for something that says password, you're not going to find it, because this is just a big, you know, ugly string that's being passed to your system. So if we go on to the next. So how would I test this atomically? So this little video, this is just like a very simple, like straightforward, this is what this should look like. There we go. So it's just simple copy paste. I've got a PowerShell data ENC. So it says testing evil in a safe way in 2 different colors. So nothing bad is happening to your system, but you should have something that fires here. You should have something that, like, you know, that your hunters are finding and saying, whoa, there's this weird string that's being passed on this box. And when they decode it, they're like, okay, well, this is fine. But this is, you know, something that you should be seeing.
So related to that, Adam, question from the audience. Where should we be testing this? Should we be testing this in our production environments? Should we have dedicated test systems? Where should we run these things?
Here's the disclaimer, like, don't test on things you're not authorized to test on. If you get picked up by the FBI, it's not my fault. But yeah, so there's a lot of different approaches to this. So you can easily just designate a system and say, this is my test system. I run all my things on this. And then you can kind of tune that out from some of your other systems. I would recommend, you know, you want to understand what these techniques are doing, what these tests are doing. You want to make sure you're not running something destructive in your environment. So when you run these tests, make sure that you understand what's behind them. Make sure you understand, okay, these are the commands that are being run. This is the expected state of my environment when I'm done. So with that in mind, I'm kind of a proponent of running it all over the place. You know, run it on regular systems, run it on your CSR's desktops. You know, make it look like someone who would actually clicked on a link, because that's how you're going to test your program. That's how you're going to test, like, how do we respond to these things? How do we find them? So like I said, a lot of different approaches. It just really, it's doing what's best for your program.
Cool.
All right. So so we've looked at one way to obfuscate PowerShell. So now going in through the Atomic Red team, there's a lot of different PowerShell tests. You can see there some fan favorites, some Mimikatz, some Bloodhound, a lot of really cool, things that you can do to test. But if we were just looking at how do I find PowerShell that's been maliciously, the malicious PowerShell that's been obfuscated. So here's another way. Here's another thing that you could do that's not necessarily focused on the encoded command string. So on the next screen should be a little video. Yep, and it should clear up when he hits play. There you go. So any moment now. All right, so basically this is us going to the test. We find the obfuscated test. We're just going to copy and paste this. Of course, again, you've already kind of looked through this. You know that this is something that's not going to break your environment. So in this case, what this is doing is it's going out to Pastebin and it's putting together this text, and then it's kind of compiling it into a PowerShell module on your system. So what it's doing is it's telling you, I'm going to create basically like a fake Mimikatz. Mimikatz being a piece of software that will allow you to pull passwords directly out of memory with administrative permissions. So just with that one little string, we can run something that looks a lot like Mimikatz but doesn't actually do anything evil. Right down there you say creds would normally be here, but you get the picture. So this kind of a neutered way to run Mimikatz. But that's another way that you can obfuscate PowerShell. So if you think back to that testing cycle, this is how you continue to iteratively test and say, okay, I can catch encoded commands, but now I need to see if there's any other way that someone could obfuscate PowerShells that I can't tell what they're doing immediately. And there's a great tool by Daniel Bohannon called Invoke Obfuscation. And what it will do is take a PowerShell command and it will make it completely unreadable to the human eye. It will completely face roll that thing until you have no idea what it is. So it's a great way to test a bunch of different obfuscation techniques and make sure that you can really get all of them.
Cool.
All right. So next,
oops, went too far.
Too many. So Jimmy really focused on privilege escalation. So you can do that same thing, going from attack and saying, okay, I'm going to hunt for a very specific tactic tree, or I'm going to test a very specific tactic tree. MITRE's really good at enabling both of those use cases. So let's look at a couple of different ways that you can test out some privilege escalation using the Atomic Red Team tests. So on the next page, we're back at the Empire documentation. It's a great way to really dig deep into this and see, what are they using under the hood? Because they use a lot of different other projects and modules to accomplish their goals. So here's 3 different modules, all of which have some of their own sub-modules to escalate privilege on a system. So specifically in this case, let's just take one and take it to MITRE. So power up is something that's used in PowerSploit, it's used in Empire. So you just go to MITRE ATT&CK and you just I want to look for power up. All right, so now we can see there's some software, PowerSploit, that uses power up. There's a couple of different techniques that are associated with power up. So now, okay, now I know a couple of different techniques that I can focus on for this particular tool, if that's my goal. So we can go on to the next, and let's just say let's schedule tasks. So schedule task is one of the ones that power up can influence. Here is just a very basic test. So it's run it with command prompt. You drop this into a command prompt with administrative privileges. You can assign those variables, assign whatever variables you want. And in the next screen, we'll show you a little example of that. So here, this simple as that. So you copy, you paste, you change what you want to run and when, you execute it, boom. On the system, there's a new task called spawn. And now if we go on to the next page, you can see, okay, now how do I test if my detect got this? So here we go. Here's a watch list hit, schedule task creation. If we go on to the next, you're going to see kind of that full process tree, or at least part of the process tree. You can look at the parallel processes. Kind of a good segue. You don't have to catch everything the actor does. You just got to catch them once. And then with a tool where you can visualize all the other things that are happening, just catch them one time, and then you can say, oh, there's a lot of other crazy stuff that came out of this command prompt. So now let me see, like, maybe why I didn't catch that. Does this give me additional context to tell me whether or not this is evil? All right, so let's do one more. So service creation, so modifying existing services is another thing PowerUp does to escalate their privileges. So we have a test in Atomic to create, start, stop, and delete services. You could also modify services. That's one of those ones that can potentially be destructive, so we kind of leave that to the discretion of the user. But on the next page, we should have, I think, a video. Yep. So this is kind of the full workflow. So this is kind of moving from MITRE and going through like the testing process. So we're back here. We've done the PowerUp search. We've gone to Atomic Red Team. Is there anything in here that will allow me to look for this this type of behavior? So we find a test that we want to run. We look at the variables, the things that we're going to have to change, the things that we might want to craft so it looks better in our environment or tests our controls a little bit more. We go to administrative prompt. We just paste that bad boy in there. We're going to change a couple of things. You're going to hate my tab complete skills on this one. So just going to create a service called evil. We're going to change where that thing is, or say where the binary is. So here we go. So it's just calculator. It's a service that's calculator. Popping calc is like a very common way to POC an attack. So in this case, that's great. So we created a service. Now let's do something that's probably a little closer to what PowerUp is doing. So now let's go and let's reconfig a service. And since this is one we created, it's fine. So now we're going to go to evil.exe in the temp directory. Boom, changed. So now something that might have been a legitimate service is now running a completely different executable with my code in it. In this case, that's just command renamed, but it could be whatever. So now we'll just clean up after ourselves, leave the system in a good state. So now that we've kind of run all of those things, let's go and check and see, did anything go off? So we can go into our watch lists in Carbon Black. We'll look at this service created or modified. So a little description down there when I created this, looking for this process, creating and modifying services. And here's a whole list of times where it happened. So now you can get that via email. You can get that, however you prefer. And that's showing you the full command line of what we ran. You can see where it came from that command prompt. You can see all the parallel processes that we're running. It really give you a full scope of what happened during that test. So that's kind of like quick and dirty. Like, this is how you go from an idea of there's this tool that I'm worried about to to actually testing it, getting your detections verified. This slide is the reminder to always follow your ABTs, always be testing. It's not, again, it's not one of those things that's like you do it and you're done. It's one of those things that you will always be testing, you will always be tuning, because the security landscape is always changing. Certain things are going to be easy for you to find. They're going to be easy to build high fidelity detections for. Others are going to be really, really difficult. So you're always going to need to be improving by way of hunting, building detections, testing those detections, and iterating through those processes.
Sweet. So I got some time left, and I don't know about you guys, but I'm happy to hang out and answer questions. There's a few queued up that I'll throw out there for you guys to tackle. First, there was a couple of questions related to kind of deciding where to start. So one of the specific questions is, you start from left to right and move through the kill chain, or MITRE? Do you just randomly pick a TTP? How do I pick where to start?
We have a TTP dartboard that we just throw darts at. No, I'm kidding. To be honest, yeah. To be honest, I think you need to pick a place. if I were to do this, right, I didn't have a tool like Carbon Black and I was using something like Sysmon, for example, right? I think you start where you have the best tooling and visibility available to you, right? Like, I think that is where you'll start. Don't try to reinvent the wheel. Don't try to like develop this tool to get to it. Like, see where you're at, see what capabilities you have against you, right? You can do some of this. You don't need an endpoint. You don't need endpoint visibility for this. Maybe you have security onion, right? Or, you know, a squid proxy, right? You can do some of this without having to have endpoint visibility. And so I would always go, whatever tools you have in your toolbox, start there and then build up.
Yep. Yeah, totally agree. It makes sense to start where you can do the most damage because, you know, chances are you're not going to be able to spin up new visibility like immediately in a lot of environments. You're going to take some time to decide on a tool, build it up, you know, build out the capability. So starting with what you have makes a ton of sense. If you feel like you have good visibility across the board, definitely look for ways that people can get in. Not necessarily like, here are my, you know, you don't necessarily want to look at like, what are all the 0 days that have come up in the last year? Because there's always going to be vulnerabilities in software. Like, the way that actors get access to your system is going to change like all the time. What they do when they land on the system, that is very well documented. I mean, attackers are just like anybody else. They're lazy. they do whatever works. And for the most part, most of these techniques go completely unmitigated and undetected in a lot of environments. So they continue doing the same things that they always do. So if you have some visibility on these well-known documented techniques, you have a leg up. So start from how, you know, look at the execution. Look at, you know, how does, there's like an initial access tactic, I believe, you know, in attack. Look at some of those ways that those people are getting access, and then look at discovery is another great one. It's a hard one to build detections for because the same tools the bad guys use to figure out who they are and what groups they're in, your admins use constantly. So it's one of those things that, you know, it's going to take some tuning. All that's going to be very specific to your environment, but very, very valuable. And mostly one of the great things about humans versus machines, humans can look at a list of processes and very quickly pick up one and say, that one's weird. The rest of these make sense, but that one's weird. And that can help enable, you know, your hunt.
Right. So here's a specific one regarding privilege escalation. You know, good example, but is there other, like, what other key indicators are you kind of focusing on if you're hunting priv-esc type attacks?
So I think, you know, right off the top of my head, if I were to sort of look at things outside of like UAC bypass, is like account reuse, right? Mimikatz, right, is behaviors related to like LSAS being scraped, right, and credentials being dumped, and then things like PS exec, right, being used. Like, all of those things, they have another ends to the mean, whether it's lateral movement or whatnot. But at the end of the day, like, they're taking somebody else's user account. Maybe, you know, an IT admin logged into Jimmy's machine, right? And that guy never logged out, right? And so his tokens are still there, and you can harvest those, and technically you've escalated your privileges, right? Like, I think scoping it around user behavior is also a really interesting one that leads to a lot of really good threat hunting outcomes.
Yeah, absolutely. Yeah, so I mean, you know, depending on how well you know your environment, you know, you can do some user behavior stuff too, because if you have people that do nothing but pick up the phone and enter data into a web form all day, like, they should never run PowerShell. And you can probably tell all those users and say, if any of these users ever runs PowerShell, I need to know about it yesterday. So yeah, that's definitely a good point. You probably notice if you go and look at the priv-esc tactic tree in MITRE, outside of bypassing UAC and even sometimes in the effort of bypassing UAC, most of the privilege escalation is due to misconfigured services or, you know, unhardened systems. So it's one of those things that if you do some due diligence and just kind of look and say, do I have any unquoted service paths? You know, are any of my services going to be, are they going to fall victim to DLL hijacking or something where that process can be affected? It's one of those that like a preventative, you know, IT and hygiene mindset will really save you a lot of grief going down the road, because a lot of that stuff is really hard to identify. Again, unless you're looking for modifications to services and scheduled tasks, those are some good ways to really figure out if somebody is monkeying with something that they shouldn't.
Yeah, and to sort of add on to that, Adam, I think, oftentimes as defenders, we look at the immediate thing like, oh, I caught the bad guy, right? But like your after action is like, you don't always need to buy a security tool to then say, hey, how do I prevent this from happening in the future? Group policy in Windows is very powerful. And as Adam said, you can do a lot of things to like limit your attack vectors to the point where like the bad guys are going to kind of give up and move on to somewhere else, right? So I would say that's like a huge thing, right? And like low hanging fruit, like your service accounts in your enterprise shouldn't have interactive login rights, right? Like that's something that's oftentimes overlooked. And when we do incident response and things, you can see it's like, oh, the SVC SQL account's now moving around everywhere in the environment, right? Like that's very common. And literally that's one checkbox you got to set in group policy, and then that can't happen anymore, right?
So here I got a couple more building off of the similar questions. So I'm going to lump these two together. I think they're somewhat related. So the first is, have you actually seen a UAC bypass that works when credentials aren't required to be entered? And then tangential, but I think in the same class of things, is what kind of indicators would you be looking for around a LSAS or a WMIC type attack?
Good one. So I would say the first part is the atomic testing framework that Adam just went over has a number of one-liners specifically around the UAC bypass where without any user interaction or anything, you'll get calc to pop with admin rights. For whoever asked that question, I would certainly just go download that and try that one-liner. It will cause no harm to your machine, we promise. And yeah, you'll see like for real life this happens. And like I said, we see samples all the time that reuse these publicly available UAC bypasses. Yeah, the second one around WMIC and LSAS, it's a tough one. But at the end of the day, you should be looking at like untrusted processes and things that you've never seen before touching LSAS, right? It's loud when you like open a file handle to the LSAS process. Now that does take, some security tooling will help with that, but I do know that Sysmon will kind of give you that ability to show like cross-process type behaviors, right? That process injection type behavior into those very specialized processes like LSAS.
Yep.
Adam?
Yeah. So so we see all kinds of stuff for escalating privilege. A lot of times adversaries don't have to escalate privilege because they start out as admin, because admin is kind of everywhere for a lot of organizations, which goes back to the hygiene thing. But I've seen things like well-known vendor software signed up to date that's affected by DLL search order hijacking, just dropping a malicious DLL. So looking at module loads is one of those things that is really, really valuable for a couple of use cases. So one is someone loading if there's an application that should be loading all of its DLLs, its libraries from System32, is it loading anything from my temporary directories? Is it loading anything from C Windows Temp? Is it, from my user space? That's a great way to find like a lot of evil and even just some weird stuff. Like, is there weird software running in my environment? There's like for Mimikatz, there's well-known modules that are loaded every time that thing kicks off and scrapes passwords out of memory. And with the event of process hollowing and all that stuff, you can find those modules loaded in pretty much any process on the system. So just by looking for a handful of DLLs being loaded into a process, you can find Mimikatz no matter where it is on your system. So this is a couple of ways like that we see actors like acting in the wild, things that they're doing that you can find with a very simple query.
Cool. So a couple more, we're kind of switching flavor here on questions. So the first one was, what kind of metrics would you report up to management to kind of justify this type of program, or to kind of advocate for building more hunting into your processes?
Yeah, Adam, you go.
No, the only metric that like, it's funny because I get this question sometimes like from customers and prospects and stuff, and it's like, how do I justify this? Like, look at the dwell time for actors in an environment. Like, it's measured in like years, like months and months. Yeah, it's crazy how long people can stay in your environment. So dedicating some percentage of your analyst time to searching for well-known documented behaviors, like that should be a gimme. Like that's not something that you, like, if you're a security manager, you want these people doing this search. And if you want to quantify that, make them show you the report. You know, if you do a hunt, you should come back with like an all clear, or this is what I found and what I did about it. And here's the detector that I built so I don't have to hunt for that thing again. You know, that's how you can verify that someone's, you know, not just, you know, on Reddit all day. They're actually going off and finding some evil. Although there's some good stuff in the NetSec subreddit, so don't ban it at the proxy.
And to sort of add to that, right? Like, I think the obvious thing that everyone wants to say is every time I set out to threat hunt, I'm always going to find evil, right? And I hate to break it to you, but that's not going to be the case. And so, but there are so many nuggets that you do get out of it, as far as like, you're sort of like documenting normal in your network from an IT perspective, right? So just because you don't find a hacker, you might have found misconfigurations from an IT side, right? That you can then go to your team and say, hey, I found these, and look, like this just closed the gap, right? Like it's so don't think about it like the literal thing right in front of you of finding hackers. Like the dwell time piece, I think, is super important, and that is like the definitive metric, right? But I think as far as like uncovering the unknowns in your network is just as important, right?
Absolutely. Yep. You'll solve a lot of IT problems that way too. So like your ops people will thank you. It's like, we could never figure out what this database went down every night. Well, now you know.
Yes.
And I'll add from speaking from the other side, like things I've looked for justification on activities like this. One of the things you can also present is what tools are actually working. You know, what tool, you know, by doing that testing, by doing that hunt and doing that cycle, you can start showing, hey, this tool is adding value, this tool is not. You know, hey, I'm saving the company money, we really don't need this tool, it's not providing visibility, or it's providing redundant visibility. And that cost savings should go into my paycheck or getting me more people to help me keep up with all the work we've got, type of thing. But showing that value of, hey, this is where, these are the things we're finding, but also this is where, you know, we have visibility, and this is where we should be investing, is, you know, from another management perspective of how you can justify that activity. So another question here. So where and when do you draw the line between threat hunting and incident response procedures when you're performing an atomic testing and hunting engagement?
Atomic testing and hunting engagement.
Can you repeat that one more time? There's a lot of stuff in there.
Yeah, so
that's what I said.
The question is, and I'm reading, is when and where do you draw the line between threat hunting and incident response procedures when you're performing atomic testing and hunting engagement?
So I guess the way I interpret that is you're using the atomic testing framework to, you know, exhibit these unit tests to, you know, make sure you're getting alerting and visibility on these things. But while you're doing that, it may lead you to find threat actor behavior. I guess that's how I'm sort of interpreting that question. And, you know, I think that's that fine line where you kind of know what you guys have executed in the environment, right? You kind of know what normal is after doing those threat hunting processes that we went over. And so, you know, to me, it's pretty black and white in the sense of that's normal, that's not normal. And I think overlaying that with maybe the behaviors that you would have expected to see is sort of going to lead you down that path of we should probably call people or get the lawyers involved or whatever your incident response process is.
Yeah, I'll just add to that, like don't go hunting without being prepared to perhaps go into an incident response.
Great point.
Yeah, it's always a thing. So, you know, make sure that your incident response plans are well known by the people who are doing the hunting, so that they know how to move from one process to the other. As far as like, how do you draw the line between, you know, testing, hunting, or testing your IRP? It's all about intent. So if you want to, if you want to test and see, can my hunters find this? Sprinkle some stuff out there, make sure your people who are there to respond know that it's happening, know that it's coming, and vice versa. So if you're going to do something, you want to see how quickly your team responds to it, don't tell anybody except for management and like the people that absolutely have to know, and then see if your analysts detect it and how they run through their processes.
So, okay, here's another one. And I'll paraphrase basically, but the question is, have we seen technology vendors build signatures to match atomic tests. So basically, have you seen any vendors or try and use cheat codes?
I don't know that I have. Jimmy might have seen some stuff out there, but I don't know. You could, I mean, I'm sure you could write in write in something that just looked for accessing the GitHub, but I mean, I wouldn't work with those people.
I've actually seen like real live threat actors pulling artifacts like from GitHub repos, right?
Yeah.
Like not specific to the atomic testing, but like, yeah, that's what they do. It's an easy way to like, hey, GitHub's allowed right through my proxy or whatnot. Yeah, I would say that oftentimes I have seen security vendors make signatures for like user agent strings that may be specific to testing frameworks, or stubs of code blocks that may be in testing frameworks, right? Where it's not being genuine in the sense of it's not getting after the meat of the attacker behavior.
Yeah. It's not, yeah, at the end of the day, like you want something that's going to be very like robust. You want something that will find the behavior that actors are going to use. If you put something together that just gives you like a warning whenever somebody goes to a website, like it feels like you're kind of rigging the system and you're doing yourself a disservice in your test.
I agree.
All right, so we're about a minute over time. So we're gonna wrap it up right here. I will offer up. So I'm happy to kind of field some more of these questions, and we'll probably take some of these off and figure out a way to get a blog post or something else out to answer some more of these questions that are there. Also feel free if you got questions. I'm always happy to talk to people at conferences via email, whatever. So my email is really easy to remember. It's just joe@redcanary.com. So if you guys want to pipe those through me, hit me up on LinkedIn, Flying Monkey 127 on Twitter, any of those kind of resources, send them my way and I'll get them over to Adam and Jimmy. Also, reminder that we have part 3 coming up, where we go into building more detection capability and kind of bringing part 1 and part 2 into a complete picture. So tune in for that. These will be recorded. We'll be sending out, I believe it's coming through, you should be getting an email to anybody who registered, and we'll make sure that we post to social media and other places where you can download and get the recordings after the fact. So thank you for your time. I apologize for anybody who didn't get their question answered specifically here, but we will try and get some additional resources out there to address those. So thank you and have a good day.
Bye, everybody.
Yes.